Arduino started as a project that we did at the Interaction Design Institute Ivrea back in 2005, but it has some roots in previous projects that we worked on, because we wanted to make a tool for our student that was more modern than what was available on the market at the moment, especially because the tool that everybody was using, this thing called the Basic Stamp, in Italy was costing at the time about 76 euros, that's like $100. So it was very expensive for the students. They wouldn't do too much work because they didn't want to spend money on buying many boards that expensive. So what happened, we started to look at possible alternatives, and also we were working on processing, a processing language, because Casey Rees, one of the founders, was one of the teachers in Ivrea. So we thought, why don't we try to figure out how to make processing for the hardware? So we worked with the student who did a thesis on the topic, and that produced the wiring platform. And Hernando Barragan, is a Colombian student, worked on it. And then after Hernando made wiring, we started to figure out how could we make the whole platform even simpler, even cheaper, even easier to use. And then we started to essentially re-implement the whole thing as an open source project. We wanted it to be open source so that everybody could kind of help and contribute. Then we had another issue that there were a lot of discussion about the school closing. So we decided, okay, let's try to make this platform and open it up as much as possible.
Entonces pasamos de discutir lo que nos gustaría tener a discutir cómo hacerlo. Y el momento que empezamos a discutir cómo hacerlo, Máximo había hecho algunos experimentos con una tecnología, yo había hecho experimentos con una tecnología diferente, discutimos sobre qué era lo mejor y decidí, por mi parte, probar la tecnología que tenía Máximo, porque era mejor desde un punto de vista de la compatibilidad con diferentes sistemas operativos. Revisé el hardware, encontré un par de bugs, lo arreglamos y bueno, ya nos pusimos a hacer placas. Es decir, el proceso desde el momento que empezamos a trabajar en serio a tener una placa fue un proceso de 2 días y el resto fue ya software.
While I was kind of in the middle of this, I met with David Quartielles, who started to sort of help me in the project and became a major contributor, and then together we kind of made the first Arduino hardware. Then we had David Mellis joining as a student to write the software. Then Tom came in as an advisor, and finally then Gianluca came in as the person who was able to manufacture the board itself. So that's how the team kind of formed, by adding people by the skills.
We'd been using wiring boards and wanted to port a bunch of programs to a cheaper microprocessor, basically, to install in some installations. And I helped write like a little compatibility layer so that all the old programs could run on the new processor. And then just being in Ivrea and not wanting to spend too much time on my actual thesis, I spent more and more time like working with Massimo and the other guys developing Arduino.
I knew that there was this development of this hardware equivalent to processing. And I went over to Ivrea in June of 2005 to do a workshop with them on another subject. And they showed me the Arduino board at that point. And I looked at it and I said, you know, this is great, and it definitely works for your school, works for my school too, but I think it could be a larger thing. And I think more people would want to use this. And Massimo said, well, that's good feedback, thanks. And then I went back to the States, and a couple weeks later they wrote to me and said, you know, we want to go further with this, and we want to try and get it to the larger world. Do you want to join us as part of the team? And I said, yeah. And it was just, for me, it was a case that this is a tool that I could see using myself, and therefore I could believe in actually helping to get it out to a wider world.
After the first prototyping, there was the needing or the desire to start to manufacturing something in a more professional way and in a more commercial way, because all the first sample was and mounted was doing just to let them work. After Massimo and David decided and understood the prototype was working, they needed to make a bigger batch. So we decided to work on 200 units, and I made a little redesign, a little design for manufacturing in order to produce them. It was a test. They agreed with their school, the Interaction Design Institute and the K3 of Malmo, to buy 50 each. That was a good starting point. That means we will not lose all the money, but at least half was coming back. The selling price was exactly what we paid for. I think we earned €1 for each board. That is nothing considering all the effort we put inside. And after some advertisement, after some speaking with friends, this movement started to move. And so we received the first call of first customer asking for one board. They was a friend of Massimo and David, but it was the beginning of something.
A few months after meeting, he said, "Hey, Nate, SparkFun, you guys should carry this thing called Arduino." And I looked at it, and at that time it was the through-hole version, the RS-232 version. And I said, "This looks very, very interesting," but I didn't really understand it. And I hadn't wrapped my head around it. And so he said, "You know, Tom, I don't think it's for us. We don't really do kits. We're not sure how people are going to react to this." And so I decided against it. It was a few months later, 6, 7 months later, that Arduino came out with the full USB version and fully assembled and tested and ready to go. And Tom, again, came to us and said, "Hey, SparkFun, you should really carry this." And I said, "Oh, okay, well, I'm not really sure. You know, we'll bring in 20 and see how they sell." And that was the first 20 out of about 40,000 at this point.
La primera vez que escuchamos oír hablar de Arduino fue a David Cuartielles en una actividad que se llamaba los Jueves de Media Lab, que fue de hecho fue la primera sesión de esa actividad que seguimos haciendo.
Y él suelta ahí su rollo y al final, ¿no? Después de hora y media de estar escuchando toda la historia de David, aparece que está involucrado en este proyecto, pero una cosa muy pequeña, ¿no? Entonces, para mí era como, wow, por fin, o sea, a ver, David, ¿por qué no empezaste por aquí, no?
Os quiero hablar de Arduino. Arduino es el último proyecto que lo terminé la semana pasada con el director técnico de este señor. Le dije, ¿no crees que sería bueno que hiciéramos algo que pudiéramos ofrecer gratis? Dice, gratis. Digo, sí.
Y a partir de entonces, bueno, pues también a través de Gustavo y de seguir el contacto con David, pues organizamos un taller de Arduino en octubre de 2005, que creo que fue uno de los primeros talleres, si no el primer taller que se organizó de Arduino. El último día David propuso hacer pequeños prototipos, se llamaba "Trae tus cacharros viejos y hagamos algo con ellos". Y de ahí surgieron proyectos que fueron muy interesantes. Entonces la gente continuó haciendo pequeños instrumentos electrónicos, pequeños robots.
Ahora ya está arreglado.
Well, let's see. At the time, I was senior editor at Make. Make was only a couple years old, and I had heard about this Arduino project, and I saw it online, and I said, wow, a lot of people are starting to talk about this. I should check it out. And I got one of the boards, and I said, wow, this is fantastic. Beginners are going to love this. It runs on Mac, it runs on PC, it runs on Linux. This is exactly what everyone wants. At the time, a lot of people were using basic stamps, they were using all sorts of microcontrollers, and I come from using design tools like Flash and processing, and I'm like, oh, this is perfect. Exactly what I think everyone's going to want. And this was in the beginning of when Make was starting to have a store. And so it took a little while, and it's very hard to do international money transfers. Basically, we started selling Arduinos and Make right away. And then later on, when I started working with Lamore, who's part of Adafruit, she's the founder, we also said right away, this is a fantastic tool for getting people doing the things that they want to do with electronics, not necessarily learning everything first, but getting the application done. Like I want my dress to blink. Very hard to do if you just wanted to learn electronics. With an Arduino, you can get that done in a few minutes.
Just start the confetti video.
Yeah.
Maybe. So this is sort of our demo bay where we have a number of our projects set up. And this was a project we did for a single night event that used Arduino as sensors. And we have it set up here. The way it works is we made these giant maracas that when you shake them, they create these explosions of confetti. And in the original install, it was on a giant sphere, but here, each one of these has an accelerometer in it and a Bluetooth controller, and it's sending it to the computer, and then we're generating these graphics. And it's all related to a specific event where we wanted people to lighten up. It was at a cocktail party, and we wanted people to really let loose and feel more free than they typically do at these sort of events. And maybe we should show you quickly the Luminode project over here. This was a project we did early on in the lab, thinking about network lighting. And the way it works is there's sort of a family of lights. And the main light here, you pick it up and you can sort of tune a color by twisting it. It'll set the color. And then these others are the sort of the children. As you sort of play with them, they'll all start to come into sync. So we're really interested in these social relationships that people create through technology. So in this case, it was sort of syncing a number of people up who are all using the same thing. And then we sort of extended it out to use architectural scale lighting and off-the-shelf lighting equipment.
The very first thing I tried to do with an Arduino was run a 3D printer on an Arduino, which I probably should have started out with something simpler because it was really difficult. And I didn't know anything about electronics. It was just like stumbling blindly and trying to get it to work. But eventually I got it to work, and now we sell these MakerBot 3D printers, which actually run on, there's multiple Arduinos in the machine. So this is a 3D printer, and what that means is it takes a 3D model from, you can download one from the internet or design it yourself or scan in a 3D model of an object, and then it prints with plastic. So this right here is a filament. And so what happens is this plastic gets slowly pulled down into the extruder head here. And when it's done, you'll get a real object that is exactly what you wanted. So you have a digital file that you give it, and you basically say, make me one of these. And so you hit print, and then this machine will make it for you. So it'll make 1 or 100 or 1,000 of them if you want. And which is great because there's all sorts of cool open source things that this will make for you. So you don't need to have a laser cutter or a PCB fabrication thing to really participate in open source hardware. You can just design something, this will sit on your desk and print you out stuff. So it's one of the things I really like about this is that this allows you to apply the idea of open source hardware to things that are very, very basic that you would not otherwise consider to be open source hardware. So we have there's an open source whistle, for example. There's an open source bottle opener. Over here on the wall, we have, right here, there's an open source coat hook. So we have a coat hook. This is open source hardware. There's a file on the internet you can download, and if you have a 3D printer, you can print out as many coat hooks as you want, and you don't have to pay anybody anything. If you want a bigger coat hook, you can make it bigger. And it's just this wonderful idea that we can apply this idea of open source to all of these common everyday things that we use in our life. Like what we're trying to do is open source everything. Would sort of kind of been a crazy idea 10 years ago, are now actually, there's a path that we can take to get there. And people are starting to take it seriously.
Open source hardware is a fantastic way to make sure other people can look at your designs and improve them. Open source hardware is a fantastic way, so you don't have to answer emails, people asking can they necessarily use something. You've put the license out there. You've said open source hardware for us means you could take our stuff, you could do whatever you want with it. You just have to do the same thing we did. Release it back, allow other people to do whatever they want with, and they can sell it as long as all the attribution, all the credits, all the things that you've requested are respected. And so far it's worked out great. If you look at Linux, it's a perfect example. If you look at Apache, all these things that run the web, it's all open source. If you had to pay someone or talk to someone or license something every time you wanted to put up a website, we wouldn't have the fantastic world of information sharing we do. So I look at Arduino as a physical representation of all the great things you got with open source software, but now it's starting to happen in hardware.
We will hit a level where people will be creating hardware in the same way that people were creating books after movable type became cheap and easy to replicate. And I really think that that's the level of the open source hardware revolution, is we are looking at something like a Gutenberg event where movable type will change how people read, write, and share information. And only in this case, it will be how we create and use physical objects.
The idea behind having control over these physical objects and being able to manipulate them at will and not be afraid to take them apart, to see what's inside, to really know everything that's going on. That's something really behind the open source hardware for me, and something I'm really passionate about.
Of course, open source means that you're making it for the community at large, based on work that other people have done. So it's kind of like I'm taking one step up a ladder, and then I'm helping other people go further up the ladder.
El problema que hay es que por culpa de la estandarización y por culpa del sistema de patentes se cerraba la posibilidad para mucha gente de aprender cómo funcionaban las cosas. Y quedaba reservado a un grupo de gente que son los hackers, que por tener mayores conocimientos técnicos podían o se sentían con la capacidad de abrir un elemento electrónico y mirar qué es lo que había dentro. Y bueno, a mí el hardware abierto significa volver a tener la posibilidad de mirar qué hay dentro de las cosas, pero hacerlo de una forma que esté permitido, o sea, que sea éticamente correcto, que sea legal y que permita mejorar la educación. Entonces, para mí el hardware abierto realmente es un sistema que permite a la gente educarse en cómo funcionan las cosas, cuando vivimos en un mundo en el que hay más ordenadores que personas. Entonces, tenemos que comprender cómo funcionan las cosas, ya no para poder repararlas, sino sencillamente para comprender cómo funciona nuestra vida. Y yo creo que es una necesidad, ¿no?
At the beginning, on the whole question of open source hardware versus open hardware, open source, it's still very complex. It's a very complex situation. There's still not very defined standards or licenses or processes. For us at the beginning, it was a specific need. We knew the school was closing, and we were afraid that lawyers would show up one day and say, everything here goes into a box and gets forgotten about. So we thought, okay, if we open everything about this, then we can survive the closing of the school. So that was the first step. Then we started to figure out that that was a way to get a very nice ecosystem of people participating and making extensions, making derivatives and helping. And then our activity of talking to manufacturers and making them to build things became an interesting study on how there could be a business model that would apply to open source.
Y para nosotros fue muy importante, ¿no? Como un espacio cultural, ¿no? De experimentación, intentar aplicar también esas lógicas de las herramientas libres a los procesos de trabajo. Y eso fue también la idea de Interactivos, un espacio donde la gente pudiera desarrollar sus propios proyectos, pero que también hubiera gente que se pudiera involucrar como colaborador, porque el proceso es abierto a la participación de cualquiera. Entonces, para nosotros es ahí siempre, no sé, como una relación muy estrecha y una sensación de que siempre tratamos de inspirarnos en algo tan sorprendente, ¿no? Como todos los procesos del software libre, y en este caso, que no habíamos oído nunca hablar, ¿no? De que hubiera también hardware libre, ¿no? Y esto pues, nada, fue como un hervidero, ¿no? de posibilidades que se dispararon en muchas direcciones.
I love open source hardware. I think everything should be that way. It's great for education. I like sharing what we've learned, and it's easy for the kids to find out more. And it would be great if they could build their own things. Yeah.
I did not learn microcontrollers until my middle years in college, till the end of college. And I was really blown away by how easy it was to use, Arduino namely being the forerunner development board. I think given the right series of events, if Arduino and electronics could be taught in high school, I think there's a big future for not only engineers but also artists, also digital media, interactive design people. If they can learn that in high school, imagine how much more they can do later in life.
Cuando el Arduino le manda la señal, el Arduino controla exactamente lo mismo que harían estos dos pulsadores. Esto está hecho para grabar y reproducir tocando los botones a mano. Pero si le colocas unos optoacopladores, estos dos de aquí, desde la controladora, puedes puentear el pulsador y activar el pulsador con una señal eléctrica que salga de la controladora, desde la programación. Entonces, por eso el Arduino es tan potente, porque puedes controlar cualquier cacharrillo que funcione con pulsadores. Es una herramienta fantástica para que los chavales de esta edad tengan un contacto con un montón de realidades que viven. O sea, primero para que aprendan que hay otro lado, aparte del lado de consumidor y de usuario y mando a distancia con los electrodomésticos, que hay una forma de conocerlos por dentro y de tener el control otra vez, ¿no? Porque estos chicos ahora mismo todos tienen un montón de cacharrería que apenas saben cómo funciona. Con el Arduino puedes destripar un poquito cómo funcionan las cosas y por lo menos mostrar algunos esquemas que a ellos les permitan tener una cierta visión del mundo tecnológico que va a haber alrededor. Y luego es muy divertida. Es muy divertida y sirve para enseñar electrónica, sirve para enseñar a pensar, sirve para enseñar a tener proyectos a medio plazo y trabajar en equipo, para participar en una comunidad, documentarse.
The potential for students when they're just learning how to use the computer to learn how to make things with computers, to me that's powerful, and what that would actually mean long term for students with only $50 to be able to plug something into their computer and make something with it over and over and over again and iterate it and share it, and the type of creative community that can engender in young people, to me, I think that's going to change everything, and really excited to see what happens as it develops.
Ahora mismo Arduino tiene 120.000 usuarios o 130.000 usuarios, o, bueno, lo contabilizo por circuitos vendidos. Bien, el tráfico que estamos registrando en nuestra página web es de 15 millones de hits al mes, que se traduce en unos 600.000 hits al día. Esto es sabiendo que se emplea activamente en universidades, que lo emplea gente que hace sus proyectos personales y demás. Imaginemos que de repente se fuera a emplear en colegios de secundaria.
El futuro no va a ser tecnológico en un sentido, ¿no? Que va a ser mucho más, un poco más social o por ahí, ¿no? Que va a haber una especie como de eclosión de un montón de gente que va a empezar a usarlo, ¿no? Y luego vuelvo a aterrizar el Arduino.
Del puerto USB. I definitely see Arduino taking one path of just being very easy to use, even easier than it is now. So making it easier for beginners to get into it.
One of my favorite distortion pedals, a big muff with my favorite microcontroller board, an Arduino.
Se multiplicaría la base de usuarios por 10 o por 20. Entonces, si esta gente de repente empezara a compartir sus ficheros en la red, todo esto no podría ser soportado, no funcionaría.
Here's a robot.
If I tilt, you can see the light goes left, I go up.
I want Arduino to always be a tool that people who have no understanding of computers can look at and can get an understanding of how a computer works from.
But I sell these, and so that's part of how I make my living.
Para que esto siga así dentro de 10 años, lo que hace falta es que nosotros podamos seguir creando nuevo hardware, que la comunidad nos siga realimentando y que nosotros podamos incluir sus cambios y sus propuestas dentro de las mejoras necesarias. Y lo que yo veo es que dentro de 10 años espero que haya por lo menos un ordenador Arduino. ¿O qué? Pusimos a hacer placas, es decir, el proceso desde el momento que empezamos a trabajar en serio a tener una placa fue un proceso de 2 días y el resto fue ya software.
While I was kind of in the middle of this, I met with David Quartielles, who started to sort of help me in the project and became a major contributor, and then together we kind of made the first Arduino hardware. Then we had David Mellis joining as a student to write the software. Then Tom came in as an advisor. And finally then Gianluca came in as the person who was able to manufacture the board itself. So that's how the team kind of formed, by adding people by the skills. There were a lot of discussion about the school closing. So we decided, okay, let's try to make this platform and open it up as much as possible.
Entonces pasamos de discutir lo que nos gustaría tener a discutir cómo hacerlo. Y en el momento que empezamos a discutir cómo hacerlo, Máximo había hecho algunos experimentos con una tecnología, yo había hecho experimentos con una tecnología diferente, discutimos sobre qué era lo mejor y decidí, por mi parte, probar la tecnología que tenía Máximo, porque era mejor desde un punto de vista de la compatibilidad con diferentes sistemas operativos. Revisé el hardware, encontré un par de bugs, lo arreglamos y bueno, ya nos pusimos.
Arduino started as a project that we did at the Interaction Design Institute Ivrea back in 2005, but it has some roots in previous projects that we worked on because we wanted to make a tool for our student that was more modern than what was available on the market at the moment, especially because the tool that everybody was using, this thing called the Basic Stamp, in Italy was costing at the time about 76 euros, that's like $100. So it was very expensive for the students. They wouldn't do too much work because they didn't want to spend money on buying many boards that expensive. So what happened, we started to look at possible alternatives, and also we were working on processing, a processing language, because Casey Rees, one of the founders, was one of the teachers in Ivrea. So we thought, why don't we try to figure out how to make processing for the hardware? So we worked with the student who did a thesis on the topic, and that produced the wiring platform. And Hernando Barragan, is a Colombian student, worked on it. And then after Hernando made wiring, we started to figure out how could we make the whole platform even simpler, even cheaper, even easier to use. And then we started to essentially re-implement the whole thing as an open source project. We wanted it to be open source so that everybody could kind of help and contribute. Then we had another issue that